Hi students, now we will start a new chapter. We will start applying what we learned about the vectors, acceleration and something like that. We will start section 4.1 with forces and interactions. We need to know what is the force. It is not energy, it is not power, it is just force. It is an interaction between objects. Maybe it is an interaction between two objects or more. Maybe it is an interaction between an object and its environment. For example, a moving ball or a moving car will interact with its environment, which is an air, by resistance. Okay, maybe an interaction between two magnets or magnet and a piece of iron. This interaction is a force between objects. This force has many definitions or shapes or something like that, but we'll see that we have two shapes, which are the pull and the push. It's easy to know the pull and the push force. Also, we have intercontact force and non-contact force. If I need to pull or push, I need a contact point between the two bodies. If you need to measure the resistance between a boat and the water should contact the boat to make or to construct the resistance force. This is a contact force. There is a non-contact force like the gravity. There is no contact between earth and objects. There is no contact between earth and sun. The gravitational force between them are not contacting force. The magnetic force is also the same, and the electric force is the same, is non-contacting force. We have in nature four main forces: the gravity, the electromagnetic, which is electrical and magnetic force. We have nuclear forces, which are the strong and weak. We will deal with the first two of them, gravity and electromagnetic. The electromagnetic is the main force between the particles, between any objects, particles or atoms. The dominant force is the electromagnetic. The force is a vector. The vector has a magnitude, which is a number. The vector in physics has a unit. Force has a unit, which is Newton. Also, because it is a vector, so it will have a direction in I, J, K, east, or positive X, negative Y, and so on. So the force is a vector. And we need to use the resultant force vectors formulas like the Pythagorean theorem, and we can find the phi, which is the angle for that resultant force, which is tan inverse of the y component over the x component. We will see that via the examples. Now, we have some examples for these forces. For example, we have gravity attraction. We have electric, maybe attraction, maybe repulsion. Also, a magnetic force is the same, has two shapes, but gravity has just attraction. We have friction force, which is negative force for any motion. The friction force is negative to our system of motion. If the body moving forward, then the attraction force will be backward. So its sign is negative. We have also the normal force. The normal force is the contact force between two bodies contacting to each other. For example, We have these two bodies. Now we have a normal force from the first one to another, the other one, and we have a normal force from the second toward the first. And the normal force has an angle, and its angle always 90 degrees over the surface. The normal force is important. It will keep the body at the top of the table. It will not dive inside it. The particles will not dive and will not mix between the two bodies. So the normal force between two bodies, and it is normal. We need to study also superposition of forces. Maybe you have a body, one body, and there's two forces on it. So I have force number one, we have force number two. We need to add and subtract them to find the final force. For example, if we look at this object on a surface, there is no movement. What is the forces, or what are the forces on that object? We have an object. The object has a mass. Then it has a weight. The weight is always downward to the center of Earth. Also, we have a normal force upward in the opposite side of the weight. In this case, it is normal always to the surface. Its angle is 90. What if we don't have the normal force? We have just the weight. Then the object will dive in this surface and will go downward. What if we have just the normal force and we don't have the weight? Then the body will start flying. We need to know that the normal force always equal to the opposite force, which is the weight in this case. Because if the normal force is greater than the weight, then the body will start flying. If the weight is more than normal force, then the body will start diving. For example, when we sit on a seat with a sponge top, then we will start diving in the sponge until the normal force equal to the weight. Then we will stop diving inside the sponge. The sponge will not be compressed anymore. So in this case, because we have the weight is equal to the normal force, for example, if the weight is 10, then the normal force is equal to 10 with an opposite side. So we have two vectors equal in magnitude but opposite in direction. Then the resultant is 0 Newton. As we told, the weight is force. The normal is also force. Its units are newtons. Now in this case, we don't have any horizontal forces. We have just vertical forces. We have another example, simple example here. We have a person pushing this box with force 50 newtons in this direction, in x positive direction, in positive x direction, or in I hat direction. So the force has a magnitude, which is a number, which is 50, has a unit, which is Newton, has a direction, which is positive x direction. Also, we have the weight, because we have a mass. Also, we have a normal force, just this first one. Sometimes we have friction force between, which is a contact force between the object and the surface. The friction force always in the opposite side, which is a lowercase f. So we have now vertical forces, which are the weight and the normal force. We agree that they are the same. Sometimes they are not the same. We have horizontal forces, which is the applied force, which is capital F, and the friction force, which is the lowercase f. If we need to find the resultant force, if we assume that F friction force is equal to 1.5 Newton in the opposite direction of the motion, which is negative x direction. What is the resultant force? We have two vectors. The first one is in positive x direction, 50 newtons. The second one in negative x direction, 1.5. So the resultant force in the resultant horizontal force is 50 to the right plus negative 1.5. Negative means to the left, which is 48.5 newtons. Because we have positive sign, then we know that is in positive x direction. Let us now look at the other examples. Okay. If we have an object, the same like the first one here, but we have applied force, not vertical, but with an angle 30 degrees above the x positive direction. We have a friction force in the opposite direction of the motion, which is 1 Newton. We have the weight, we have the normal force, we have the mass, which is 2 kilograms. We will start using the mass now. If you remember in the previous sections and chapters, we don't use the mass. There is no m in our equations. Now we will start using the mass. Now if I need to find the normal forces, here we know that the normal force is equal to the weight. The normal force is equal now to the weight, but there is another component of the applied force. The applied force has two components, in x direction and in y direction. By the way, the weight is mg multiplied by g. M is 2, g is 9.8 downward. So the weight is 19.6 newtons. We have the normal force upward, we have the weight downward, we have this force, applied force, has two components. One of them is upward, as we see, which is Fy. We have another one which is Fx. Fy, it is the magnitude of that force multiplied by sine theta, because theta is taken from x direction. So from x direction we will take the cosine theta, from y direction we will take sine theta. So F in y direction is equal to the magnitude of that force, which is 10, multiplied by sine theta, which is 30. Sine 30 is half, multiplied by 10, it will be 5 newtons. Now the vertical forces, we have the normal force upward, we have the weight downward, we have the y component of the applied force, which is F sine 30, we compute it, which is 5. This all together are all the Fy for the forces. This is the summation sign, this is Fy. Fy means F in y direction, or F in the perpendicular direction to the motion, to our system, or we can write it in this way, F perpendicular or F vertical. What is the normal force? Which keeps the object in contact with the surface and on balance on that surface, will not move in upward and downward. The weight, it is the amount of the force between the attraction force between the earth and that mass, this mass. F sine theta is the vertical component of the applied force, as we see. Now we need to compute we can compute the normal forces. Now the mass will not move in y direction. It will not start moving in y direction. So the acceleration in y direction is 0 because it will not moving. Its velocity in y direction is 0. So the total forces will be 0 in y direction. We are talking just in y direction now. The total forces, which are the normal, the weight, and F sine theta, all of them are equal to 0. The normal force is unknown now. We don't know it. Now it is not equal to the weight directly like the first example. Now the weight is known, which is 19.6. The vertical component of the applied force is 5. All of them are equal to 0. Now the weight is, the normal force is upward, so it will be in positive direction, in positive sign. The weight is downward, so it will be negative. The vertical component is upward, so it will be positive. So the normal force, when we order the equation, it will be equal to 14.6 newtons. Because it is positive, it will be in positive y direction or upward. So the normal force is 14.6. The weight is 19.6. The normal force is not equal to the weight. We have another acting force, which is 5. Okay, if we will add 5 to the normal force, it will give us the weight downward. We will see another examples like that. What about the horizontal forces? Now we have the applied force, which is 10, and the angle is 30. We need to add all the x component for these forces, which are the applied force component and the friction force in opposite direction. Okay, F cosine theta, because theta in the direction of x, and the friction force with negative sign. F is equal to 10 cosine theta. It will be all together will be equal to 8.66 minus 1, which is the friction force. This will be equal to 7.66 newtons. Because the sign is positive, then we can understand that the direction is in positive x direction. Okay, now it is easy. We have two components. We have fx and fy. Fy is equal to 0. Fx is equal to 7.6. We can find the total force as a magnitude, which is equal to fx squared plus fy squared. Fy is 0. Fx is 7.66. And we can also find phi, the resultant direction of the two forces, which is tan inverse to fy over fx, not fz. Okay. How can we use our